Welcome to Homework Lib.
All right, so what we have here is a very standard mutual inductance problem. So first off, we know how fast the current is changing in this first coil, and it's changing at that rate. And then as a result, we know that the nth induced in the other coil is equal to this. And then we're going to go ahead and convert everything into SI units to make our lives easier later down the line. And so in part A, all they're asking us to do is calculate the mutual inductance. Luckily, there is a very straightforward formula that we can use in order to solve for that. So we can go ahead and write that out. Do a little bit of rearranging in order to solve for that mutual inductance. And then plug in numbers. And then get a value. Minus 3, negative 0.242. Put that into a calculator, and then you will get this value of inductance in the SI units of henries. And that's part A. In part B, what we're interested in is the magnetic flux through the second coil. So that's capital Greek letter phi B2, using or given the information that there are 25 turns in the second coil, and the current through the first coil is 1.20 amperes. So we can use the other equation in the summary of this section that states following. And so we just do a little bit of rearranging in order to solve for phi B2. Plug in numbers, and let's actually go ahead and do that down here to save space. So we recycle our answer from part A. Ooh. Plug in that new current, 1.20, and divide through by number of turns, and then we get the flux per turn of coil, which is measured in the SI units of Webers, 3.27 times 10 to the minus 4th Webers. Great. Excuse me. And in part C, we are given the rate at which the current is changing in the second coil. And that's 0.360 amperes per second, sorry. And the question is asking us what is the induced nth in the first coil. And so we just go back to basics, use a different version of that first equation, just its mirror image, in order to solve for that. And then it's just a matter of plugging in numbers. Again, relying on the answer from part A. And then this new number of 0.360 in order to get an induced nth of negative 2.46 times 10 to the minus 3 volts. And we're done.